Okay, going on to 2.9 weighted averages video number 2. On this next video, we're going to talk about word problems. They're not really mixture problems, but they're more distance problems. And you could do this two different ways. I want to explain both ways. One way is logically, and another way is using the formula that the distance is really the rate times time. Okay, distance equals rate, which is a speed, times time. So here's an example of where we're going to use D equals R times T. Okay? So two trains are 550 miles apart heading towards each other on parallel tracks. Okay? So they're far apart. And I want to start by doing a sketch. Let's say that one train's over there, another one's over there, and they are 550 miles apart. Okay? Now, train A is traveling 35 miles per hour. So you have a train going this way at 35. And then you have another train going this way at 45. Okay? So when will the trains pass each other? Well, you could use logic and say that after 1 hour, how far is this train this way? After 1 hour? 35. And after 1 hour, how far is this guy this way? So together, how much distance have they closed after 1 hour? How much distance have they closed after 1 hour together? 80, right? So logically, from here to here, from here and here, go after 1 hour, they've chopped off 80 from that 550. After 2 hours, it would be another 80. After 3 hours, it'd be another 80 that you keep subtracting, logically. So the fact is that if you take your 550 and divide by the 35 and 45 together, which would be 80, that would give you your final answer, which is 55 divided by 8, which is almost 7, so about 6.9. Yay? So that would be your answer as when the trains will pass each other. 6.9 hours. Now, that's using logic. That's using logic, but the real way to do this is to set up a problem similar to the ones we set up before, where we say, okay, we know that the total distance from one train to the other is 550. And that's the total distance, right? Now, we know that one train travels the distance of rate times time, okay? So, in other words, I want to put the distance plus the distance equals the total distance. So what is the distance of this train, this blue train? It's rate times time. The rate is 35 miles per hour. So I want to put 35. Now the thing is, I don't know the time. I don't know if it's 3 hours, 5 hours. That's actually what we're trying to solve. So I'm just going to put 35t. And then I put plus. Now the other distance of the let's call this one the black train. The black train is traveling 45 miles per hour. So the distance of the black train is really 45, but I don't know how many hours. So I'm going to put the 45, and I'm also going to put t because I don't know how much time it takes, right? How many hours it's going to travel. So this becomes the equation of 35t plus 45t, which will equal 80t equaling 550, and there's your equation that you could solve by simply dividing both sides by 80. And that's how we're going to get the same exact answer as up here, 6.9. So one way was using logic to find out the answer 6.9. Another way is to use distance equals rate times time to say that the first distance train plus the second distance of the second train equals the total distance 550. and then you solve that equation, and you'll get t, which is really the time, which is 6.9 hours. In this case, 6.9. So, two airplanes are traveling at 1,500 miles apart, heading towards each other. Okay, so the distance from here to here is 1,500 miles. These airplanes are headed towards each other. Boom. Okay, no, they're not going to crash. They're going to pass each other, right? So they are headed towards each other. Plane A is traveling at 450. That's what it says here. So I put 450 miles per hour on plane A. I did it in red. Plane B is traveling at 745. It's going even faster. The question is, when will the airplanes pass each other? How long will it take? That's probably the better question. How long will it take? So you could do this question two ways. One way is logically. Logically, if 1 hour passes, how far will this plane be after 1 hour? If it's 450 miles per hour, after 1 hour, how far is the plane going to be? 450 miles, right? Okay, so after 1 hour, how far is this plane going to be? 745 miles, right? So if both of them are traveling at the same time after 1 hour, how much distance have they closed in? It's not going to be 1,500 miles anymore apart from each other. After 1 hour, it's really the distance of A, and that's 450. So after 1 hour, that one's going to be 450 miles. That gets subtracted from the 1,500. But after 1 hour, you also get to subtract the 745 that one traveled. So the total distance that you could subtract from the 1,500 after 1 hour will be how much?
1,100.
That's right, 1,195. Okay, so after 2 hours, you're going to be able to subtract twice as much, and so on and so on. So the fact is, after each hour, this is how much total distance is traveled in both directions, right? So after 1 hour, they actually chop down 1,195 from the 1,500. So the question is, how many hours will it take for them to actually pass each other? Well, if you know how much they're traveling together, the total distance, you're going to be able to simply take the total distance original. I don't know if that even made sense. The total original distance, 1,500 miles, and simply divide it by 1,195. Now we are able to use calculators, so let's use one. So if you divided this with the calculator, you get 1.25, and that's really talking about hours. That doesn't mean an hour and 25 minutes. It's actually 1.25 hours, right? So that would be your answer right there. The other option would be to use algebra to create an equation and solve. Okay, so let me, I can't. So we already have the answer here. I just deleted my work. Let me go back and use algebra. So what do we know about algebra? What do we know about distance? Distance equals rate times time, okay, RT. And the rate is really the miles per hour. So since they give us the total distance apart, you could convert this kind of like to a mixture problem where you say something plus something equals the total distance of 1,500. Okay, let me write down total distance right above that. So the 1,500 is the total distance, and how do we get total distance? You get it by adding the first distance with the second distance, right? Adding them together, and that'll give you your total distance. Now the thing is, we don't know the distance of A, so we could substitute, in a sense, the RT, the R times T, to represent this D. So the R times D is the rate, and the rate of plane A is 450. So you're going to put 450, that's the rate. Now the time we don't know, so we're going to keep it T. Okay? And the distance of the blue train, again, we're going to use the R times T. So the distance of the blue, did I say train? I did. Plane, I'm sorry. The distance of the blue plane is 745. That's the rate. So you're going to put 745. And again, you don't know how long. That's what we're actually solving for. So you're going to put t right there. So you really have 450t plus 745t equals 1500. So let's just solve this equation by combining like terms. And when you add 450 plus 745, what do we get? 1,000. And that is t equals 1500. So all we need to do is solve for t. You could just focus in on this equation right here and divide by 1195 and divide by 1195. And if you do that with the calculator, you should get that same exact answer, 1.25. So it's up to you if you want to just start thinking logically of how much distance is actually reduced with each plane, or train for that matter, whatever it is that's traveling. Or you could use algebra using distance equals rate times time to plug it in and create an equation and solve.